Okay, this is Andres, and this is group number 26. My classmates are Weimar, Maria Paula, and Oscar, and we chose the topic precision agriculture, focus in crop recommendation according to the soil characteristics and the environment. Why we choose it? Well, so we have a few data sets among these ones, which are student habits versus academic performance, cost of international education, renewable energy, and Pepsi versus Coca-Cola sales. All of these, we rejected them because of their significant drawbacks. For example, most of the datasets, they had missing label outcomes. They were too complex, and they were not clean. We needed advanced statistical normalization, or we require economic knowledge of it. Also, they involve too many variables such as tuition fees, living costs, exchange rates, scholarships, visa policies. There was also inconsistency in the data formats. For example, some countries, they use different currencies or time frames such as semesters or trimesters instead of years. Some of the datasets cover policies, technology, climate impact, and economics, and each needing separate expertise. And what happened, for example, with Pepsi and Coca-Cola was that the data scarcity. So essentially, we couldn't find any data about it, or whatever we found was we have to buy it, or we have a request authorization to use it. So instead, we use crop recommendation just because it was a dataset that was clearly labeled. It was had clear columns such as nitrogen, phosphorus, potassium, temperature, humidity, pH, rainfall, and crop type, of course. It covers also multiple crops such as rice, maize, banana, watermelon, etc. It has a diverse environmental conditions, making it very useful for predicting modeling. Also, one of our team members, she's an agricultural engineer, and she provided some insights and guidance to understand the data sets and the outputs, plus some additional insights in the soil. So the takeaway of all this is that the dataset it has a structure, it's labeled, has clean columns, it's relevant to the team, and also the actionability of it. So because of its direct farming applications, it can address precision agriculture, helping farmers selecting optimal crops for their specific soil environmental conditions to maximize the yield. Resource optimization, reducing wasteful use of fertilizers, water by matching crop requirements to local conditions, and also climate adaptation by assisting in crop selection as traditional growing regions experience climate shifts.
Hi everyone, my name is Weimar Alvarez. I'm gonna show you how we work in the query to decide how we work in the machine learning, how the project show us our results. So I'm gonna show you our query. First of all, we open to read our dataset. Our dataset contain eight columns and have 2,200 rows. The information contain a chemical part and part that is describe the crop. The idea is to get the information on one column that is called level, and the level is the name of the crops. Okay. In this part, we can show you a little description of each column, how many information there are in each column, the mean, the standard mean, the minimum, each quartile, and the maximum. And this is all the crops that this data set has. Of course, this is just a little sample of many other vegetables, many other things that you can grow, but this is a little sample. First of all, after that, once we have the information, we decide to calculate which model we are gonna train. So according to our classes, we decided to use a K-neighbor classifier, and how the other the teachers teach us, the idea was to use cross validation to know which K could be the best in order to train the model with the best accuracy possible. So in this model, using cross validation, the cross validation shows us this is all the data exporting during the cross validation, and if I want to choose the best key is 3, because the maximum accuracy could be the 98%. Yeah. After that, we import the train test split to divide the dataset and to start to train it. But before of this, we have to decide the test size. How everyone know the test size, the idea of the test size is to know the percent, which percentage of the dataset you will use for train, and which other percentage you will use for test. So how this part is really important, we decided to use a little script to in order to evaluate and calculate which accuracy could be better. So once this little app is running, our app shows us the best test size is 0.13, and this 0.13 rise one accuracy of 1995. So this is really good. Here there are the classification report with the precision, recall, F1 score. I show you the accuracy, I show the precision for each level, and how the false negative and the true positives could be calculated. And this is a little graph to show how the accuracy versus the test size is shown us. The first time we choose 20%, but once we finish this model, this little app, we decide to choose 13%. 13%, yes. Once the model is trained, here in this part, the model is trained. We use the random state 40, we use KNN with the neighborhoods we decide before. We fit the model. Once the model is training, we start to use a little examples to know how the model is working. So in this for these two small list, the model predicts rice and pig on peas. So using this example, we can say the model is totally training. So we start to graph the information. For example, in this graph, we decide to show how each crop is distributed using just the chemical part, phosphorus, magnesium, and the other one I forgot, sorry. This is we create a little level encode to change the level part. If you notice, the level part was strings, the names of the crops, rice, orange, here in the list. So now, after that, the list is just numbers. Why? Because I had to work here. This is the list. So the rice is the number 20. Why? Because this graph, I start to work with more graph in order to show how the characteristics of the data insert in the dataset could be show us how is distributed the data inside each data. For example, if I show the humidity for maize or rice, this is the data, and how the data is distributed in block spots, and we will use, the idea was to use this in future predictions. For example, this is the pH for the each crop, and this is the most important part of our job, because we decide to create a little application. The idea was one user insert data, and our app predict the crop, the ideal crop, and once this is show us, the idea is to show the level of each column, each characteristic, and the point of the data you are insert in. For example, let me show you. I'm gonna show you, and let's start the app. So in this moment it's running everything. It's running everything. Yes. Okay. So I gonna enter information. For example, I'm gonna enter for nitrogen, I'm gonna use 14. Phosphorus, I'm gonna use 75. That is this data. For phosphorus, calcium, sorry, I'm gonna use 44, 24. For temperature, I'm gonna use 24, 54. For humidity, I'm gonna use 57, 34. For pH, I'm gonna use 6.4, and for rainfall, I'm gonna use 118.36. And once this is finished, the predicted level is pigeon peas. This is the data I entered, and this is the graph for each characteristic. So how my partner said, for example, in this case, this was the data the user insert. So I can see the most of the crop use this part. So the person who wants to grow, in this case begonias, have to work in decrease a little bit the phosphorus. He has to decrease a little bit the calcium. The temperature is good, but the humidity it's high, so they have to work in the humidity as well, and the pH is in the high level, so they have to work in the pH as well. If you notice, the area have a little problem with the rainfall, so they have to work with irrigation areas. So that's the idea of our machine learning model. I hope could be clear. Thank you so much.
Hello teacher, my name is Maria Paula, and in this section of video I will talk about our AI project for crop recommendation, especially about the importance, the advantage, the disadvantage, and the improvements. The agriculture is very important for food production and the economy, but many farmers still make difficult decisions without enough information. For example, choosing the grown crop for the soil and weather can cause bad results and waste of money. That's why we create the AI system that help farmers to choose the best crop based on the condition of their land. Let's go to talk about the importance. This system uses machine learning to analyze data as nitrogen, phosphorus, potassium, temperature, humidity, pH, and rainfall. With these features, it can predict the most suitable crop. It is important because it can help farmers make better decisions, increase the productivity, and save resources like water and fertilizer. It can also support governments and agricultural companies in planning and sustainability. What advance of our project is that it's easy to use. The system only needs a few inputs and give the clear recommendations. It also has high accuracy. For example, our key nearest neighbors model had an accuracy of around 97%. And another benefit is that it's work fast and can give results in real time if used, and specifically it is used in an app. The problem is that, like this advance, I have some limitations. Our model only works with the crops in the datasets, so it cannot suggest crops that are not included. Also, the model depends on good data. If the input data is grown or missing, the prediction might not be useful. And right now, it does not consider market prices or crop rotation strategies. The improvement for us in the future, we can improve this project by using more data, adding economic factors, and making a mobile app that farmers can use directly in the field. And we can also train the model for specific regions and languages to make it more local and accessible for every farmers and for every people that maybe in this moment doesn't have accessibility to the to the internet, to any connection. Thank you for your time, and we believe that the AI can be a strong tool to help agriculture become smarter, more efficient, and more sustainable.
Hello everyone, my name is Oscar Martinez, Group 26. Today we share key insights, highlights, and the main conclusion for our project. Predicted and crop recommendation for agroclimatic data using machine learning. We began with a well-structured 2,200 record dataset contained the 7 variable format, actually measured soil nitrogen, phosphorus, potassium, temperature, humidity, pH, and rainfall. Because it was already clean and fully labeled with the 22 crops types, we could focus on modeling instead and data writing. After testing several algorithms, the simplest one, key nearest neighbor, classified with K3. On 5-fold cross validation, we saw a sharp accuracy peak at key 3. When we look at that in a move to blind test set, the model scored 97.6% accuracy, correctly predicted, and 644 on 660 cases. That level of precision makes the tool trustworthy enough for the real world use, especially for smallholders who can risk the trial and error. Because KNN in instant base, we can show farmers with a recommendation was made. Box plots reveal how rice cluster and higher humidity and neutral pH white pigeon pit thrives in slightly alkaline soil. A confusion matrix heat map let us point the handful of crops that still can mix it up, mainly those with overlapping nutrient profiles. Visual transparency turns an EA black box into the decision compiler, translating accuracy into the volume according to FAO yield responses curves. Matching crops to soil can lift yields 2 to 4 percentage. Synchronizing nutrient demand with supply saves in up to 50% fertilizer input. And lightweight models means the whole system can live in a mobile app, ideal for a region with limited connectivity. We also candid about rigs. The source data in India-centric, so performance could drops elsewhere. Bias monitoring and local retraining are essential. Subsistence crops must not be on the recommended with track class balance to work against that. Finally, agronomy's oversight remains crucial. The model is advisory, not prescriptive. To conclude, a simple transparent KNN model can solve a real agricultural pain point with almost 98% accuracy. The system provides better yields, lower weights, and data-driven agribusiness opportunities. Responsibly deploying demands continued bias checking, regional retraining, and human-in-the-loop validation. Future work will add satellite imaginary economic variables and a sample model to push performance beyond today's ceiling. That's all for today. Thank you very much for attention. We believe this project shows how accessible AA can empower farmers, boost sustainability, and drive innovation in agri-tech. Okay, thank you very much.